Good morning, students. Last time in the series of mathematics program, we looked at nature of quadratic roots for additional maths. Now, we're going to look at the second part, which shows the application of the nature of quadratic roots. You have a curve defined by y is equal to ax squared plus bx plus c. You have a straight line defined by y is equal to mx plus d. If I draw these two graphs on the same axis, what can happen according to you? Either the line cuts the curve into two places, line cuts the curve into 2 points, distinct points, or line is a tangent. Line touches the curve. Line is a tangent. Here, line does not cut the curve. Right? So, these are the three possibilities. That is, the line will cut the curve at two distinct points, and we are going to say there are 2 points of intersections, or 2 roots. Here, the line will touch the curve. Line is a tangent to the curve. Here, line does not cut the curve. Now, what are we finding here? The points of intersection of the curve and the line. So, how do we find point of intersection of the curve and a line? We would solve simultaneously. What are we going to solve simultaneously? The equation of curve and the equation of line. So, the first step to find point of intersection, step 1, would be solve equation of line and curve simultaneously. Solve equation of line and curve simultaneously. How? You can use various methods that exist, substitution, elimination, or we can simply, in this case, equate. What was the equation of curve? ax squared plus bx plus c equal to, for the line, mx plus d. What are we going to do? Step 2. Transfer all the terms on the left-hand side. ax squared plus bx. The mx will go. So it will become minus mx from right-hand side to left-hand side. Plus c was here on the left-hand side. The plus d goes on the left-hand side becomes minus d equal to 0. Right, step 3, what are we going to do? Calculate the discriminant. You remember what was the formula for discriminant? B squared. Everything that you see in front of x. What do we see in front of x? I can see b in front of x. I can see minus m in front of x. So, what will it become? We square that. Minus 4. What is the coefficient of x squared? A. And then the constant here is c minus d. So, what is the discriminant? Coefficient of x, b minus m to the squared minus 4 times coefficient of x squared times the constant. That's the discriminant. Now, let's see what happened in this case. When the line will cut the curve at 2 distinct points, the discriminant will be positive. If the line touches the curve, the discriminant would be 0. If the line does not cut the curve, the discriminant will be negative. These two cases, we often combine them. Line meets the curve. Discriminant is greater or equal to 0. So, whatever we learned in part 1 now is being applied to the point of intersection of a line and a curve. So if we have a quadratic, a parabola defined by the quadratic equation, y is equal to ax squared plus bx plus c, and a straight line, y is equal to mx plus d, then 3 things can happen. Line cuts curve at 2 points, line touches the curve, or line does not cut the curve. So, to find point of intersection, we equate both. Curve equal to line. Step 2, we transfer all the terms on the left-hand side and then calculate the discriminant. B minus m, whatever you see in front of x, squared. I see plus b, I see minus m. B minus m, I calculate the value, I square. 4 times coefficient of x squared times the constant here. So I get the discriminant. For line to cut the curve at 2 different points, discriminant has to be positive, greater than 0. For line to touch the curve, discriminant has to be 0. And when the line doesn't cut the curve, discriminant will be less than 0. So, from the discriminant, we can immediately conclude what's going to happen between the parabola and the line. We'll now take an example. We have a line, y is equal to 2x plus c. And then you have a curve, y squared is equal to 4x. I would like to know what would be the value of c. What is the value of c for line to be? What is the value of c? Now we'll leave it like that. For line to be a tangent to curve. can have value or values. So, remember, what was the first step we said? We want to find point of intersection. Let's solve these two simultaneously. Here, I would choose the option of substitution. So from the line, y is equal to 2x plus c. So what I'm going to do, in equation of curve, where I had y, I'm going to write 2x plus c to the squared is equal to 4x. So I have replaced y by 2x plus c. So here I have used the method of substitution. I can expand this, so this becomes 4x squared plus 4cx plus c squared is equal to 4x. So 4x squared plus 4cx minus 4x plus c squared is equal to 0. So we are going now to find the discriminant. What is the discriminant? Everything in front of x. What do you see in front of x? 4c minus 4. 4c minus 4 to the squared. Coefficient of x squared, 4. And whatever remains is called a constant, so I have c squared. Let us simplify. So this becomes 16c squared minus, if we expand this bracket, 2 times 4, 8, 8 times 4, 32c plus 16 minus 16c squared. So we see that we have plus 16c squared minus 16c squared. This gives us minus 32c plus 16. That's the discriminant. Now, if line is a tangent to curve, discriminant will be equal to 0. So minus 32c plus 16 equal to 0 means 32c is equal to 16. C is equal to 16 over 32, which is half. So if c is equal to half, then the line will become a tangent to the curve. Now, we could have asked the question, what would be the values of c? What are the values of c for the line to meet the curve? That is, the line can cut the curve in two distinct points or be a tangent. So what is the rule? Discriminant is greater or equal to 0. So what was discriminant here? Minus 32c plus 16 is greater or equal to 0. Minus 32c is minus 16. I divide by minus 32. C will become less than or equal to half. Same question. What are the values of C for the line not to meet the curve. We don't want the line to meet the curve. What would be the values of C? That would guarantee that the line will not meet the curve. So, what is the rule? The rule says discriminant has to be negative. So what is discriminant here? Minus 32C plus 16 less than 0 minus 32C. So, divided by minus 32, C would become 16 over 32 greater than half. Now, in this example, the line is a tangent if C is exactly half. We have seen that. The line would cut the curve at two different places if C is less than half. And the line will not cut the curve if C is greater than half. So, we know exactly what are the different values of C will make the line either cut, be a tangent, or not to cut the curve at all. So, we have used here discriminant in order to understand what are the points of intersection of the line and the curve. So, in the first part, we learned about discriminant and how discriminant tells us whether the curve is going to cut x-axis or not. In the second part, rather than taking x-axis, we have taken a line. And we have seen that a line is going to be a tangent to the curve provided discriminant is 0. A line is going to cut the curve at two distinct points if the discriminant is positive. The line will not cut the curve if the discriminant is negative. So this example illustrates that we had a line was equal to 2x plus c and a curve, and varying the different values of c will ensure that the line is a tangent, cut the curve at 2 points, or doesn't cut the curve. So my dear students, this brings us to the end of the 2 parts on nature of quadratic roots. I hope you have enjoyed these 2 programs with us. Until next time, it's goodbye from us.